We don't buy things that have no impact. We don't buy things that nobody's interested in. And we certainly buy lots of things as a society that are vulnerable.
Hey everyone, this is the Industrial Security Podcast, and I'm Nate Nelson, here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Spencer Wilcox. He is the Chief Security Officer and Executive Director of Technology at PNM Resources, and PNM Resources, among other things, serves electricity to 790,000 homes and businesses in New Mexico and Texas. Our topic is supply chain cybersecurity.
Here's you and Spencer.
Hello, Spencer, and thank you for joining us today. Before we get started, can you say a few words about yourself and about your role at PNM Resources?
Sure. My name's Spencer Wilcox. I started in cybersecurity in the late 90s when I was working in law enforcement. And since that time, I've managed to move into utilities in about 2004 in a large East Coast utility. I've been in that space for most of the time since then, and am now I'm the Chief Security Officer here at PNM Resources, which is a large regulated utility in the state of New Mexico and Texas here in the United States.
And our topic today is supply chain cybersecurity. Can you tell us a bit about, start at the beginning, what is supply chain cybersecurity? Can you define the problem for us?
Sure. So supply chain cybersecurity and just defining it is a problem, actually. When you start looking at how each entity is defining this problem, it's kind of like the blind man and the elephant story. Everyone wants to define it based upon their experience with it. So supply chain, when we start thinking about it, is not just the manufacture of equipment and then receiving it on the end. It's everything from the original component design, the architecture, the programming, the component design and manufacture, as well as all of the sales entities, legal channels, shipping, and everything that goes in between the entity making it and the entity receiving it. And then it also includes all of the integration of that component and additional work that gets done by a third party once that component is on site. So when you start thinking about something like cybersecurity in the supply chain, you're really talking about the ability to do traceable transactions throughout that entire chain, all the way to final implementation and go live on a product. Whether that product's a traditional cyber product, an IT product, if you will, or an OT product. So operational technologies like industrial control systems and SCADA systems in particular may have much larger supply chains than some of the more traditional IT technologies that we're used to every day.
So you've talked about a lot of the pieces here. Can I ask you, what are we worried about?
So what are we worried about? Anywhere along the line, you can have either by accident or by intent, someone tampering with the product itself. So imagine for a moment that I'm going to manufacture, a relay for an electrical system. So I'm going to specify out all of the parts and all of the components that would go into it to include, let's say, a chipset that I'm going to have manufactured by a semiconductor company in China, just for example. So that chipset could be modified during the design, during the engineering, or during the building. So the idea, though, is that we're going to, what's concern, okay, the area of concern, I guess, for the federal government in the United States and other governments is that there could potentially be some tampering or some intentional implementation of a backdoor or other uh, failure mechanisms into the product during the supply process. Now, depending on where you are in the world, you can have different stages of that supply chain tampered with, right? So I could tamper with it during shipping, for instance, or I could tamper with it at that manufacturer. I can tamper with it during the application development or coding of any of those components. I can also tamper with it either intentionally or unintentionally during the installation of the product or during its integration with other components within the system. So the more complex the system, the more complex the potential number of points are in the threat landscape. When you think about it as being very similar to the concept of your attack surface in the MITRE attack framework, right? But in this case, it's the attack surface is all of the components that were procured, designed, programmed, assembled, or integrated within your entire fleet of systems.
Andrew, a point of clarification here. Is what Spencer's referring to a case where a hacker intercepts a supply chain and then inserts their own backdoor into a product, or where a company itself would build an intentional backdoor into their own product?
It's all of the above, actually. And it's, as will become clear in the rest of the interview, it's a very complicated space. Let me take one example. Something that's been in the news for a while has been Huawei. The Huawei supplies, among other things, 5G telecoms cellular equipment. And there's been a debate in many countries. I think it's been banned in some countries from use on the cellular infrastructure. It's still under debate in other countries. And the concern there is that Huawei is a Chinese business. It's a big, powerful Chinese business and presumably has close ties with the Chinese government. And so the concern is that the Chinese government could order Huawei to insert a backdoor into its products and let the government or intelligence agencies use the infrastructure that Huawei, using Huawei equipment in another country's infrastructure to do bad things, whatever they are. Intercept communications is probably the easiest one to imagine that communications infrastructure would let you do. It's more complicated than that, though, for a number of reasons. With the Huawei example specifically, there was an investigation that I read about in Secure Computing magazine. I heard of another investigation that the government of the United Kingdom did. They might be the same one, but this investigation I just looked up here to get some facts. Finite State is a security firm that specializes in connected devices, and they report that they scanned 10,000 Huawei product firmware images and found that over half of them had hard-coded passwords, had hard-coded cryptographic keys, had an average of 100 known vulnerabilities each. In some cases, we're using libraries as old as 20 years old rather than the newest and, presumably more secure libraries. And so their conclusion was that the equipment was intrinsically insecure. The equipment was, on average, below average in terms of security. To me, the bottom line is you don't need a backdoor in a product that's already insecure. Anybody skilled in the art could break into this equipment. You don't need to be the government to order a backdoor to go in. And so, the question is, Huawei is being debated because they're, alleged to be under the thumb of the Chinese government. But, if any fool could break into it anyway, should other companies, let's say Western companies that are producing equally badly secured stuff, be banned as well from supplying national infrastructure because it can be broken into as well? It's a murky area.
And I do see what you're saying, but to some extent, I would have to say that the distinction is still important. So there is still a difference, in my view, between a product that is fundamentally insecure by virtue of maybe incompetency versus a product that is otherwise well built, but specifically intentionally built with a backdoor for malicious purposes. To me, that seems like two different things.
It is two different things, but the outcome might be the same. But it's mostly the latter that you pointed out. It's mostly the deliberate sabotage of product, either by the vendor or by third parties in the course of handling the product, that is going to be the topic for the rest of the episode here. So that makes sense in principle. Do you have a couple of examples in mind that you could give us and sort of speak to the problem?
So recently there was a Wall Street Journal article about a large transformer that was diverted from a utility in the United States and may have been collected by the Department of Energy. Now, I can't speak specifically to that, but what I can say is imagine for a moment that along the way, the intelligence community picks up word that there may be something wrong with a device that has been shipped here. Or imagine for a moment that this transformer that's assembled in China, let's say, and it specifies parts from all over the world, that all of those parts are then shipped for final assembly in China. Well, what opportunities are there for tampering throughout that entire process that could cause the components to fail at a pre-specified time, right? Or cause them to fail upon some triggering mechanism. Think of it as a time bomb built in within the system. So this would be the kind of concern that the intelligence community has been talking about and has resulted in so much scrutiny all the way to the point of regulation in the new NERC-CIP 13 standards. The first thing that we have to understand, though, Andrew, is the risk, right? What's the likelihood that this is going to happen? And the answer is, well, it depends, of course, on what the outcome is and whether or not that outcome is within the adversary's wheelhouse, right? So one of the key challenges that we run into is we, as utilities in particular, don't really have a clear understanding of how often this is happening. And that's something that we think that the federal government should really, step in to help understand what that threat landscape is and be able to share better information on who it is that we should be avoiding, in that supply chain.
So the transformer that Spencer was referring to, this is a Wall Street Journal article. They reported that a large transformer, by large I mean big. This thing was reported to be, I think, over 200 tons. A large transformer was ordered from a Chinese supplier, and when it arrived in the United States, instead of being shipped to the power utility that had ordered it, it was diverted to Sandia National Labs, presumably for inspection. And shortly after this, the presidential executive order came through, ordering certain supply chain security control measures be put in place. Not much more is known about that transformer. There's been no public report of the results of that investigation. There's been no real analysis of it other than, hey, a big transformer was diverted. The only thing I saw was that it was not, in a sense, commandeered from the power utility. There were signs that the power utility voluntarily surrendered the transformer to the government because shortly thereafter they canceled support contracts with the supplier, saying don't need those services anymore. It's not going to be installed. So there was, that's about all that's known about this transformer.
What would a sabotage of the kind that you guys are talking about look like in theory if it were to take place?
Well, if we're talking this transformer, I find it really hard to imagine. Now, I'm not an electrical engineer, but in my dim understanding, transformers are passive devices. They are, it's two coils of wire with different numbers of windings in each coil, one coil inside of the other, and they just sit there, and electric alternating current flows through them and changes voltage because of some kind of induction thing that I bluntly don't understand. But they just sit there, and the power goes through them. Now they're oil cooled, but I don't know that there's any pumps in the transformer. I thought they were external. The only automation on a transformer, so there's nothing to control. Controlling the power flows happens outside the device, is my understanding. There's all sorts of monitoring on the device. So you monitor current, you monitor temperature, you might monitor vibration if there's any kind of shaking going on from this 60 cycle alternating current. I don't know. You certainly monitor voltage, because if there's an over voltage condition, you risk burning out the insulation, and that's very bad. Then you got to replace this 200-ton transformer. And the problem with transformers is that if you burn one out, there's no such thing as an inventory of 200-ton transformers on the planet. These things are all custom built. If you burn one out, it takes 6 to 9 months to get another one custom built to your specifications to replace the thing. So I'm not aware of any kind of control function. You could tamper with the monitoring devices. You could report, let's say, that the oil temperature is normal, no matter how abnormal it gets. The problem with that is that, that's only going to damage the transformer if the oil ever gets too hot. And if it never gets too hot, you haven't damaged the transformer. So it's not a reliable piece of sabotage. And the thing is that governments, and again, I don't have a background in the military or military strategy, but in my dim understanding of that space, governments, when they act against another government or another nation, they want control over those actions, because peace might break out and you might not want to sabotage the other nation's transformer. So a random kind of failure, inducing random failures is not really something that it is like a government to do. So I really don't understand what they're going to find on this transformer. I'll be very surprised if they find anything, but I have been surprised before.
Something that occurs to me is the majority of what we discuss on this podcast has to do with security at the end point of what we might describe as the life cycle of the supply chain of a transformer or whatever it may be. We do a lot of theorizing about what happens at the end of that route at, a plant maybe, or a computer. We discuss less the security that occurs along that route or at the beginning of it. Andrew, I'm not familiar with this space. Whose job is it to pick up on supply chain threats? Do we just sort of implicitly trust, signed certificates, or is there a body that deals with matters like this?
This is the problem, this is a new space that the supply chain has seen a lot of interest in about the last 2 or 3 years. People just really didn't talk about it much before that. The closest you have to sort of a detailed discussion of supply chain 5 or 6 years ago is people who were supplying fake safety instrumented systems. These are alleged to be ultra reliable systems that are protecting human life. And if you have a fake one, well, it's much cheaper to produce because it's not as reliable. And if you're buying a fake one, then it's going to fail much faster than the designed life. So there's talk about counterfeits some time ago, but the talk about deliberate sabotage is much more recent. And to your question about signed certificates, they assume that the vendor has not been compromised and their certificate signing capability stolen and used to sign false firmware. And B assumes that the signed firmware is the only software running. And if you've had physical access to a device, either because you've captured it in transit or because you had access to it at the manufacturer site, you can install your own CPUs. If there's a little, computer network in some of these devices, now I don't know about transformers, but I imagine you can imagine other equipment. Let's say the 5G networks, which are computers and more computers and more computers and internal networks and hardware and software and whatnot. You could easily insert a whole new CPU in there with Wi-Fi capability so you can remote control it. And, it doesn't matter that all the rest of the software is signed. You've got an actor on the backplane now that can take malicious action. So signed certificates signed software is one piece of the puzzle, but it's a much bigger puzzle. So you mentioned, get government assistance to figure out how often this is happening. What if, the authorities come back and say, as far as we can tell, it has never happened? Does that mean it will never happen and that we don't need to worry about this?
I think it's highly unlikely that it has never happened. But I would go on to say, though, that let's assume that they can't share that information with us on how specifically it has happened or does happen. Well, frankly, what I really would like to have, if I were looking for a solution from the government, I would like them to share information that helps me to avoid those things that are of the greatest risk. Now, what SIP 13 does is it tells me that I should understand my supply chain risk. Risk is a factor of threat times vulnerability times impact, right? So if there's no impact from it, then quite frankly, you can tell me all day long that I've got a huge risk because I'm hackable, but it's not going to do anything to me or my company. Why do I care, right? That's one way of looking at the equation. The other way of looking at the equation, if there's no one who's actively exploiting it, then I really shouldn't have to care too much either, because quite frankly, even if it's vulnerable and it would be a great impact, nobody's trying to do anything to it. But neither of those is really realistic. We don't buy things that have no impact. We don't buy things that have or that nobody's interested in. And we certainly buy lots of things as a society that are vulnerable, right? So the key question becomes, how do we work together to set standards for the manufacture of equipment so that we understand a little bit better what our risks are? A key example of that would be the software bill of materials program that Department of Commerce has been working on. It's a really neat idea. It's a great concept. And what it does is it puts together this idea of where was this stuff made? How was it made? Who touched it in the manufacture of the software? But it doesn't go far enough because it's only focused on the software itself. Other ideas that have been espoused are things like, maybe we should have some sort of a certification process. An example of that would be, for instance, the common criteria. Well, it becomes so prohibitive to build to the common criteria that nobody ever did it, right? So is there some way to do either through reverse engineering or the destructive testing of systems, or like in nuclear, using something like design test software quality assurance to assess whether or not products do exactly what they say and no more? One example that I would give here would be imagine a component made for an avionics company that is installed in commercial aircraft. And imagine that it has on the motherboard of this communications package a whole extra set of communications gear and a whole processor that's not even on the design spec sheet, right? These are situations where, does this thing do what it's supposed to do? Does it have an unintended capability that nobody knew about? And those are the kinds of concerns that I think nobody's able to quite get to, because the idea of tearing apart every piece of equipment that we get is exceptionally cost prohibitive. It's very difficult to do. How would one do this? Or should one just accept the risk and move on? And that's where I think we are as a society right now. What is the level of risk that we have to simply accept and continue to move forward with?
So you mentioned common criteria and the software bill of materials. Are there other solutions that people are looking seriously at?
Well, sure. So, for instance, there are a number of companies, and I'll give the example of Fortress, who provide surveys in order to assess vendor qualifications. Do the vendors follow a secure design process? Do they have their own contractual obligations on their suppliers, right? So those solutions do a really good job of evaluating the vendor risk. Now, Fortress in particular has gone a step farther in also adding into their into their product a way to do assessments of a piece of hardware or software itself and to ask questions of the vendor. But what it still relies upon is attestation. There are other component or other ways, I guess, that this could be done as well. And some things that have been talked about, though not necessarily developed out in a full or holistic way, are things like using blockchain to verify components and where they come from, right? Also checking to see whether source, in some test of many, right, is actually accurate, whether things are being designed to specification 100% of the time. But one of the key questions that I would ask is, what are you requiring? If you look at what can you do to control it, what are you requiring in your contracts? How many of us have a contract that was written, in 2004, and that same standard language is used to this very day? So your contracts themselves offer you the greatest opportunity to actually begin acting locally while we're starting to think globally about the supply chain.
I'm a little confused. Something like blockchain that is keeping track of everybody who's touched something. If we have, I imagine one of these transformers, for example, or, in automobiles, there's thousands of parts. If you got a device with thousands of components coming from hundreds or even 1,000 suppliers, and they've all, they're all listed in the blockchain, what good does it know, or what good does it do knowing that supplier X, supplied me the part, and that they had a certified secure software development or hardware development or, development methodology, if in fact they're malicious, if they as an organization are, under the pay of some government and their job is to insert stuff into our product, they've still inserted it and they've recorded the fact that they've inserted it. I don't understand how we're protected.
So, and that's part of the challenge, Andrew, right? Is who can you trust? So when we start talking about this, think about this like the web of trust that was initiated back with PGP back in the day, right? That concept implies that we can trust people. What we would have to also do is have some means to revoke certificates or to apply a negative rating, like a credit rating almost, to those people or manufacturers or entities that may no longer be trustworthy. It may not be proactive, but it can certainly be reactive in that case. Right now, the problem is too big for any of us to really wrap our hands around. So how do we start at a smaller level? And well, the truth of the matter is that we're going to rely on government partners to be able to do this, whether that's, here in the US and Canada, working to say, what, these companies are known bad actors, maybe, right? Based on DoD experience, we'll say. Or is it something where all of us get together as utilities and do the same thing? And the challenge there is you get into anti-competitive practices laws and antitrust laws that say that we can't do that, right? So there's going to have to be a lot of policy work to make something like this even vaguely possible. But if the problem is as serious as has been made out by the government, then we're going to have to come up with a solution, and we're going to have to figure out how to either work within those constraints or have those constraints removed for the common defense.
At Waterfall Security Solutions, we are the OT security company. To help customers and other industrial owners and operators in this difficult time, Waterfall is extending our free remote screen view license program through the end of 2020. Unidirectional remote screen view is the most secure remote access possible for industrial sites. The design of Waterfall's unidirectional security gateways enables remote support while physically preventing any remote attack from reaching back into the protected network through the gateway's protective hardware. For details of the program, please visit the Waterfall Security Solutions website or reach out to your host at andrew.ginter@waterfall-security.com.
So Nate, this is coming back to your question of, signed software. If we don't trust the organization that signed the software, it doesn't matter that they signed it and said this is the authentic software that we inserted. And the analogy that Spencer gave with the certificate signing authority in terms of the blockchain only goes so far. He talked about making a list of all the suppliers of all of the world's suppliers and rating them in terms of how trustworthy they are for use in certain kinds of installations, important installations. And the analogy used was, well, we have lists like this of certificates, of encryption certificates, and when a certificate is revoked, everybody stops trusting it. It's more complicated than that when we start talking about trusting organizations, because what are the consequences if we revoke a certificate? We say, the certificate's too old. The bad guys might have decrypted the original keys because they had enough time and supercomputers. Let's revoke it. Nobody use it anymore. Issue a new certificate. The consequences of revoking a certificate usually are non-existent. Certificates are revoked routinely. But if you revoke trust in an organization, you say, don't buy anything from this organization anymore. That's going to have a huge impact on the organization's income, presumably. And in most Western countries, that's illegal. This is the antitrust laws that he referred to. It's illegal for two businesses to conspire to exclude a supplier or to deprive a supplier of business. If a supplier, has a business disagreement with a customer, that customer can eventually say, I'm so mad at you, I'm never going to do business with you again. That's perfectly legal. People who buy stuff can do that. It's illegal for large customers like big companies or even governments when I talk about governments, I'm thinking local governments, municipal governments, this kind of thing, to conspire with each other to do bad things to businesses. I'm part of lots of different standards committees. Whenever one of these committees gets together, often they read the Riot Act before everyone can start talking. And the Riot Act reads something like, okay, antitrust law demands that we do not discuss pricing. We're not allowed to conspire on pricing our competing products. We do not discuss territories or voluntarily excluding ourselves from territories so that you get that territory and I get this territory, and so on. There's things that are illegal, among them blacklisting suppliers. So the law would have to change if we're going to produce this kind of list for this problem to as part of the solution to this problem. So I understand the solutions a bit better. Can you talk about cost?
Well, cost is always the challenge, right? So imagine, one of the things I heard a gentleman from Motorola speak one day, and he talked about common criteria and what using a standard framework for design and solutioning cost. He talked about how the cell phone that's in your pocket that you can buy for $600 or $800. If it were, this was back when we had cell phones made by Motorola, by the way. So he talked about how that $600 or $800 cell phone would cost $150,000 if they had gone through the common criteria. One of the key challenges is you'd have to design a means of modularly applying some sort of control, or you'd have to incentivize the consumer to procure something at a higher cost, or incentivize the seller to sell it at a lower cost. If we are serious about security, we're going to have to buy somewhere, right? So where do we spend our money? Do we spend it on the front end of design? Do we spend it in the middle mile of resale, or do we spend it on the consumer side? Traditionally, those costs have been passed directly to the consumer. But you'll see, if you walk into a Best Buy store or whatever, you're going to find that there's the $59 cable modem. There's the $159 cable modem, and there's the $400 cable modem. Which one's better, right? Well, if I'm voting with my pocketbook, the $59 one is the one I'm probably going to buy. If I'm voting based on security, I'm going to spend for the $400 component, right? If I could incentivize the sale of that secured device by subsidizing through the government, then maybe that would be effective. The government already has programs like this, at least in the United States. And in our industry, in the utility industry, that's most obvious through the Energy Star program. With the Energy Star program, the local power company incentivizes the retailer, and they receive a subsidy on the front end from the federal government for helping out with Energy Star programs, right? And helping to incentivize the purchase of more energy efficient products. So the idea is, let's figure out a way at a policy level to incentivize the purchase of these more expensive devices that ultimately save us in the back end of cyber breaches.
But why is the more expensive device necessarily better at security? I know that it seems more likely, but why are we saying that it's, implicit?
You got to look at the context there. Spencer started out talking about common criteria. Common criteria is a military grade security certification for hardware and software components. It came out of, the original version of it was called the Orange Book back in the day, if you've ever heard that term. Was designed by, I think, the U.S. military, but was adopted by NATO. And it's a very expensive process where gurus are paid to study the thing, the artifact, hardware, software, whatever, and determine that it's secure in the face of a certain grade of adversary, of attack. And if you do this for hardware, it's expensive. If you do it for software, it's even more expensive. Not least because once you're done, you finally do all of the whole process, expensive, long, takes a very long time, and then you issue the first security update. Oh shoot, the software's changed. Now you need to recertify it and do the whole thing again. So it's a very expensive process. So in that, the example here was, if you had, it was implicit. He didn't say the words, but what I understood was, look, if you had a cell phone that was, common criteria certified, he said it would cost $150,000. If you have a $400 router, I understood him to mean it was certified in some way, and you pay for certification.
Is there any way, though, that we can deal with the price component from not the sales side of things, but the common criteria side of things? Like, is there any way to make this process less over-encumberingly expensive?
That's a good question. I'd never really thought of that. It might be possible. Now, we're talking common criteria, which is a very expensive certification process. It's the high end of the process. It's a high-end certification. I'm not sure it's appropriate for all products, but it might well be that a lesser certification is sort of more appropriate to apply universally, and if it's expensive, that a subsidy there might help. I hadn't really thought of that.
So if we have a choice in terms of our purchases, buying something that might be more expensive, with or without government incentive, versus buying something cheaper that might be somewhat higher risk, how do you make those trade-offs?
So it's a great question, Andrew. So one of the key concerns is risk management, just general risk management. And there are three things that you can do with the risk. You can mitigate it, you can transfer it, or you can accept it, right? So a mitigated risk, I can try and fix the risk itself once I learn about it. I can do something like go out and buy or add in additional controls to ensure that the risk can't, or the vulnerability can't be exploited, or try and convince people that the threat is not worth exploiting, right? I can also do some other things like reduce the impact. One example that I saw in the utility industry was one major utility decided we have all of these high risk SIP components. So what I'm going to do is I'm going to keep stepping down, and I'm going to distribute my risk across many substations and transformers rather than having a few very important ones, right? Another way is I can transfer the risk. I can look for insurance. I can look for on the policy side, a grant program or something like that to help me offset the cost of trying to fix it myself, or offset the cost of a loss associated with that device. Now, that's where cyber insurance comes in. And, one of the key concerns there is if you had a large run on cyber insurance, what's that going to do to the insurance industry, right? Another thing that I could do is contractually, I can transfer the risk back to the supplier itself. So I can write into the contract that if this device is breached, that they will share some liability for it, or they'll share some accountability for the remediation and the cost to the consumer. But, or I can accept it. I can accept the fact that there's going to be a risk and there's going to be a certain amount of loss that's going to happen. This is the same model that loss prevention people do in retail all the time. They would say, you know what, I'm going to experience some theft. So therefore, I need to expect that I'm going to have, let's say, out of $1 million worth of sales, I'm going to lose 10,000 of it. Well, we can't, unfortunately, accept that societal risk in the power industry. We can't say it's okay to have some number of our customers out for a long period of time. Because quite frankly, our job here in my industry is to keep the lights on and the beer cold, right? And people get really irate if they have to drink hot beer. So what we really want to do is we want to figure out ways that we can either do good risk transference strategies or good mitigation strategies to reduce this risk. And, quite frankly, cybersecurity is a team sport. This is not something that we can do alone. No one of us is good enough to stand up against all of the nation state adversaries that we may experience, especially, in the middle of a trade war, for instance. So we've got to look for ways that we can partner together and partner with everyone, not just other utilities, but our suppliers, our federal and state and local governments, as well as those not-for-profits that are really working to try and solve some of these problems on a larger scale. And then lastly, we need to look within our own profession. The cybersecurity and technology professions, there are a lot of smart people that can be working on these problems and are working on these problems. But how do we make it so that it's not just about profit motive, it's about societal good? Ultimately, if we can figure out a way to do that, we'll be in a better place. Of course, everybody still has to draw a paycheck while we're at it. So we're going to have to figure out a way to make it equitable.
So let me just expand on one of the things Spencer said. He talked about transferring risk, presumably by buying insurance. He talked about critical infrastructures as well. So this is a point that I think is worth emphasizing. Business risk can be transferred with insurance. You can transfer the risk to your suppliers, saying you sign a contract that says if your stuff gets hacked, then you help pay for the hack or the consequences of the hack. You can buy insurance from insurers that says if I get hacked, you're going to help me pay for the consequences of the hack. The problem is when you get into critical infrastructures. Transferring risk in critical infrastructures really doesn't work. I mean, imagine a large power outage. 10 million people are without power for 3 days. The society suffers. Businesses don't have business for 3 days. Employees may not have income for 3 days. There's a lot of loss there. And, afterwards, the lights come back on. The power company says, don't worry about that. Don't worry about that. We didn't lose any money. We have insurance. That's the wrong answer. It's not the power company that we're worried about. It's society that we're worried about. So, Spencer went through the point very quickly, but some kinds of risk it doesn't make sense to insure against. That's the wrong answer. You need a different answer. And he talked about other kinds of answers as well.
Back in the day, in the Cold War, no North American, no Western power utility would dream of buying a transformer from the Russians. They were, the enemy, in quotes. A lot of that Cold War emphasis has, in a sense, disappeared. We source stuff from all over the world. Arguably, this has made the world a safer place. I mean, this was the theory anyway. If we're all economically interdependent, and if if a large business develops a poor reputation because they're delivering sabotaged equipment, well, that's a major financial cost for that business and for that for the society that the business is part of. This is the theory. How's it going? How close are we? I mean, the executive order came through, said there's going to be a whitelist, there's going to be a blacklist. How close are we, to moving back into the Cold War era where, certain parts of the world you just don't buy anything from because you don't trust them?
Wow, that's a great question. How close are we? I think we're there, and that's part of the challenge. As we start to look at the geopolitics of the situation, it's not just Russia anymore, right? It's Russia, it's China, it's Iran, it's North Korea, it's whomever else is the enemy of the week, right? And one of the key concerns is as we start moving forward, I used to work with a guy who said that in geopolitics, if you want a friend, get a dog, right? That's kind of where we are right now. The idea that a specific manufacturer could somehow be blacklisted works great right up until the moment that they change their name and become somebody else. And that's one of the key reasons why that methodology doesn't work anymore, especially with the widespread and rampant theft of IP. As intellectual property transfers from one nation state to another, because certain nation states are certainly acting as factors for their companies and the companies that originate in their countries. We need to be cognizant of the fact that, you can get some really cool features from countries that may not necessarily be friendly to you. But those features, if you buy from a U.S. entity, let's say, or a Canadian entity, are going to cost 3 to 5 times as much. So one of the key problems is the economics of the situation when subsidized at the outset by another party, by a third party nation state, can work in the favor of the nation state who's acting in the adversarial capacity. And that's one of the key reasons why I think you're seeing the administration start to move away from it, as from that let the market decide approach, because quite frankly, it's not a level playing field anymore. Now, I say it's not a level playing field. I'm not trying to advocate for one position over another. It's just such a different philosophy between the way these nation state adversaries are working with the companies in their countries, that it can create an opportunity to insert the intelligence community's wares, if you will, into the product that ends up in our companies here in the West. Now, that said, sounds remarkably paranoid and could potentially be considered that way. What I'll also say is the markets will work themselves out over the long haul. The problem is we may not have a long haul to solve this problem. And that's why I believe we're seeing this policy shift towards something that is much more like the Cold War than frankly, like, say, 2002 or 2003, where open markets would solve the world's problems.
So that makes sense. It sounds like a big problem.
Well, I think is a big problem, Andrew. It's an enormous one. And I don't want to sound like the traditional American paranoiac, right? I don't want to be the guy who's gone off the rails and thinks that everybody's out to get him. But I am professionally paranoid. It's my job. So one of the concerns that I think we all have to deal with is we're all focused on individual components of this problem. It's a much broader, much more holistic issue, and one that we're going to have to work very hard to solve if we take it seriously. And the question is, should we take it seriously at this point? The truth is, it's, the geopolitics is raising its ugly head. The truth is that, the West doesn't necessarily play well with others. The truth is that there are other countries who are aiming for primacy right now. The truth is that there is an advantage in stealing IP and implementing your own products. The truth is that there is a cybersecurity problem, whether that's caused by criminals or nation states or, just the kid sitting in his mom's basement. We're all in this together, and we're going to have to figure out how to solve this bigger problem. I just am afraid that we're not going to be able to solve it quickly enough before something monumentally bad happens. And that's my real concern here.
I think that's everyone's concern. Everything to do with cybersecurity is let's prevent a catastrophe, especially in the industrial space.
That's right.
So this has been great, Spencer. Thank you so much. Before you leave us, is there a thought you'd like to leave with our listeners?
Absolutely. And thank you for the opportunity, Andrew. This has been great, and I'm glad to work with you guys. The opportunity that I'd like to take is just to remind everyone, again, this is, cybersecurity is a team sport. We all have to do this together. We all have to figure out ways to solve this problem. Information sharing, responsible information sharing is absolutely critical to success. And that starts with the suppliers telling the truth, telling when their systems may not be pristine. It also means not necessarily publicly disclosing that, but at least disclosing it to those people who are buying your products. Let us know if there's a problem. If you're aware that a nation state is able to use your system in an unintended way, then please let us know so we can do something about it. Even if you don't have a patch, we can at least let us work out a workaround for these things. Help us all to help ourselves. It would greatly enhance the security of society.
Andrew, your last word?
What I'd like to leave with is, Spencer's talked about a lot of different sort of mitigations for the supply chain problem. And a lot of them have to do with government. Whenever government gets involved, there's politics. And that's been part of the debate for the last little while, is a lot of people don't like regulating that products need to comply with X, Y, or Z in order to be sold. A lot of people don't like regulation. A lot of people don't like forbidding purchases from certain companies or certain countries. A lot of people don't like subsidizing purchases of products that might be more secure, or subsidizing anything like subsidizing certain security certifications. And so there's debate. But I think part of the point here is that we don't like the solutions doesn't make the problem go away. The problem's still there. We have to do something. So hence, the continued debate about what are we going to do to address this problem for the supply chain going forward. It's a complicated problem.
Then with that, thanks to Spencer Wilcox for speaking with you, Andrew. And as always, Andrew, thank you for speaking with me.
Always a pleasure, Nate. Catch you next time.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.